It's a good day to everyone out here in the virtual room. I hope you all are doing good during this pandemic period. Thank you to each one of you for being here with us today. We are pleased to welcome everybody for our very first seminar on Basics of Industrial Automation. I'd like to express my sincere appreciation to all of you who generously helped us make this event come together to become a great success. We couldn't have done it without you. So, let's start with today's topic for what we will be covering in the Basics of Industrial Training course. What is automation? Why automation used? And where automation is required? If one has to describe automation in some words, then it might be like to reduced human efforts automation is required, which performed with combinations of some machines including motors, buttons, sensors, logic controllers, power devices. Now automation is not part of industrial revolutions but also at residences such as homes/houses. All we have heard about Industry 1.0, 2.0, 3.0 and 4.0. But how those got modified we will be looking after that in the training course. As we are into basics of industrial automation we will not look for the Industry 4.0 revolution because most parts are related to the software integration where one has to handle big data, on which you have to make analytics program and then show the same using graphical user interface, GUI, software in trends, charts, tabular form. Also those again have to control through various operating levels such as administration, directors, managers, supervisors, technicians, operators, and so on. So, for the seminar, we will be taking an example from one of the most used machines in the metal processing industry, which used to manufacture the sheets from the continuous coil as you can see in the picture at the place of raw material. Every machine has three main parts like our computer and those are input, processing and the output. In the machine, a coil is input, the section where it gets cut can be treated as processing and the stacker section such as cut sheets can be an output of the machine. The machine is manufactured with various assemblies such as coil car, unwinder, pinching, leveler section, loop section, feeder section, shearing section, stacking section with conveyor. Concerning each section, it has its operating equipment, which gets drive with the help of electric motors, solenoids valves operated by hydraulics and pneumatics. Every control has various sensing devices such as proximity, photosensors, ultrasonic sensors, limit switches and others. All those devices have some electrical connections as per manufacturer design specifications, which we need to see while wiring those in the field or control panels. One of the most important parts of machines is to operate the controlling devices. It requires some button. It's the same as start a tube light in the house with the help of a button or switch and once the operations are performed those are indicated with the help of some lamps. Again it's same like our electric charger equipment where when we supply the power to device it lets the light on it even if the charger not connected to its respective devices or not. Till we have seen and talked about the machines with its various assembly with their operating devices and for those controlling devices, there are different sensors used. Panels marker. Now for all those electrical equipment wirings, it required a single compartment where a service person can look for the problem. It's the same as our society apartments where all electricity meters are located and from there each flat the cables goes as a supply. The electrical compartments are in terms called enclosures or electrical panels and those are of various types in the industry, which we will see in our panel section. In which we will not only study the type but also the different uses of the same as per application, devices. As saw the machine layout. If we divide that in two parts, one is the machine side and the other is the panel side. Then it will become easy to describe those. So automatically the devices, which used in the machine for sensing purposes, which used for controlling the actions can be best described to field devices/components and will make you understand easily during our training course. If we have named some field devices from the machine it can be the diameter sensing of the coil, measure the size of the sheet to cut, sheet depth and loop area, level measurement of the sheet, shearing depth, no. Of the cut sheet for production view, also at the stacker height checking and so on. Whereas, on the other hand, the devices, which mounted in the electrical panel and which controls the field devices for various reasons. The panel components require some special treatment as per manufacturer and design standard that's the reason they are located in panel and called panel components/devices. Drawings. As discussed a bit about devices while ago, now our next topic and it's time for drawings. Worried a bit? Don't get panic, you don't need to know any wiring drawing software. Always remember every electrical device used in automation has a specification sheet in which the operation and electrical connection diagram shown. There are different electrical devices available in the machine as well as in panel 2. It gets difficult to remember each for its wiring, so for the purpose, a wiring diagram is required. In the wiring diagram, The connections are shown for each and every component placed in the panel and field. While drawing, there are some standards that need to be followed, which will be described in the drawing topic. Also, the drawings are split into two parts. One is mechanical and the other is electrical drawings. Panel drawings that are required to draw come under mechanical drawings, whereas in electrical drawings, as we discussed while ago, the topics which we will cover under these will be single line diagrams, detail electrical diagram, arrangement diagrams, terminals drawings, cable scheduled, and a lot too. PLC and software. A programmable logic controller, PLC, is a specialized computer used to control machines and processes. It uses a programmable memory to store instructions and execute specific functions that include on-off control, timing, counting, sequencing, arithmetic, and data handling. The design of most PLC is similar to that of other computers. The PLC is an assembly of solid-state digital logic elements designed to make logical decisions and provide outputs. Programmable logic controllers used for the control and operation of manufacturing process equipment and machinery. Unlike an office computer, it has a design to operate in the industrial environment and equipped with input/output interfaces and control programming language. The common abbreviation used in the industry for these devices, PC, can be confusing because it is also the abbreviation for the personal computer. Therefore, some manufacturers refer to their programmable controller as PLC, which stands for the Programmable Logic Controller. Initially, the PLC was used to replace relay logic, but its ever-increasing range of functions in many and more complex applications. The structure of a PLC based on the same principles as those employed in computer architecture, it is capable not only of performing relay switching tasks but also of performing other applications such as counting, calculating, comparing, and the processing of analog signals. Programmable logic controllers offer several advantages over a conventional relay type of control. Relays have to be hardwired to perform a specific function. When the system requirements change, the relay wiring has to be modified. In extreme cases, such as in the auto industry, complete control panels had to be replaced since it was not economically feasible to rewire the devices with each model changeover. The programmable controller has eliminated much of the hard wiring associated with conventional relay control circuits. It is small and inexpensive compared to equivalent relay-based process control systems. So with these brief discussions over PLC and software, we will be going through basic instruction and some programs during our PLC and software topic. HMI and SCADA. Today, HMIs and SCADAs products used in a broad range of industries such as transportation, machinery, instrumentation, process control, and telecommunications along with in the audio, video, broadcast, and multimedia applications. HMI systems are particularly vital in high-stress and safety-critical operations that control processes, machinery, and transport systems. For engineering purposes, HMI specialists like engineering audit officer, encourage the consideration of several areas: ergonomics, health and safety, performance, and the presentation of information. That said, it is essential to look beyond purely ergonomic requirements of an application and consider many environmental demands that are likely to be placed upon the end product. To address risks with harsh applications, especially for outdoors, it is wise to consider stainless steel switches, keypads, and keyboards that operate reliably in these situations. These and other durable polymer-based products require minimal maintenance and deliver long-term value in terms of lifecycle cost-benefit. SCADA systems used mostly for process control. As these require a computer, so it cannot install in harsh conditions. The advantage of SCADA is to acquiring data from process and store that to the desired location, which will then taken for further analytics and to generate the reports too from those. During the training course, we will go through some sample programs to understand the thing better manner. So in this way, we finish our second last topic for the course. VFD and servo. In today's industrial and commercial world, variable frequency drives, also known as VFD, frequency drives, AC motor controllers, and inverters, are becoming a more important method of speed control. They used for all but the most demanding speed control applications. Large rolling mills are among the few places where DC motors and controls are still used. One of the reasons for this is that AC motors and their associated controls are much more reliable than the DC motors and the associated controls that to a large extent they have replaced. In current market, VFD ranging from 0.25 horsepower to 30,000 horsepower are available for use.
So drive was the last topic of our training course on the basics of industrial automation. We are very much thankful to everyone out there. We believe that beginners or those who want to get into the world of automation will surely take the opportunity for the training course. You can contact us in 3 ways for any queries: messages us on WhatsApp or email us, and the third, you can directly fill the registration form for the training course so that our team will contact you on the given details for further requirements. You need to open up the camera and scan the given QR code for the required option. We like to thank you once again, and don't forget to press the subscribe button for your own channel and press the like button onto it with bell icon for getting amazing things in the upcoming future. It's lot more to come. Bye bye, have a great day ahead.